Okay, looking at reviewing part 2 of the transition midterm review. Let's start with module 3 with a question that asks, if your average heart rate is 72 beats per minute, how many heartbeats do you average in 6 years? So this was the conversion questions. And the most popular way to do this is to multiply through by rates, conversion rates. So if I have 62 beats per 1 minute, I need to convert minutes to years. Then I can have beats per year, and then I'll multiply it by 6 to get my 6 years. So once I get minutes to years, well, I multiply that by 60 minutes in 1 hour, and then I'm going to go hours to days. 24 hour in 1 day. Remember, I know I write hours on top because that cancels out the hours. Go days to years. I need to write 365 days on top, so it cancels in 1 year. And then once I get that value, I'll have to multiply it by 6 years. So I'll save that for the end. First I'll do this, and then I'll multiply it by 6. So we need to multiply everything on top. If I do 72 times 60 times 24 times 365, that gives me, I'm going to write this on the bottom, 37,843,200, and that's all divided by 1. So I'm just going to leave it as is. And then I multiply this number by 6, again because of that 6 years. This is only per 1 year. So then I'm going to take that times 6, and my final value, I'll put it back in blue, 227,059,200. That's how many heartbeats. Okay, looking at the next question. It gives you how many times your heart has beaten. About how many years have you been alive if your heart rate is 67 beats per minute? Okay, what I want to do is actually use the beats per year from number 17. And that was the 37,843,200. If I use that, and that's how many I have in 1 year, that's beat per year, I can take the new value, the number of times your heart has beaten, divide it through by beats in 1 year, and that gives me the number of years. So if I take that number and divide it, I get approximately, and it says round to the nearest whole year, I get approximately 26.088. So we're just going to say that is 26 years old. Okay, so let's look at solving some proportions. When we solve these proportions, remember a proportion is a fraction set equal to another fraction. We just want to cross multiply. So when we cross multiply, remember it's x times 18, so 18x, 3 times 6, and those are set equal to each other. From there, we can just solve it. We'll just solve this, divide by 18, and x equals 1. Look at another example here. Cross multiply. So you have 2 times x equals 10 times 11. Divide both sides by 2. And then x equals 55. Last one here, it's 5 times 2x plus 1. Make sure you have that in parentheses. 3 times 3, which is 9. So I have to do a little distribution first. 10x plus 5 equals 9. I'm going to subtract the 5. I'm going to divide by 10. So x equals 4/10. Or if I take a 2 out of the top and the bottom, it's the same thing as 2/5. So these next ones are volume and surface area questions. I would definitely write these formulas down. I'm not going to ask you about a volume or surface area formula that I don't have on the study guide. So the ones that you have written here are probably the ones you're going to use. So in this question, number 20, it says the volume of a cone has a height of 22 centimeters and a diameter of 16 centimeters. So remember, the volume of a cone is the formula 1/3 pi r squared times h. So if we plug that information in, 1/3 pi, the radius is half of this, right? Because it gives you the diameter. So the radius is actually 8, and the height is 22. So we can go straight to a calculator here and calculate the volume of this cone. And when I did that, I got a volume of 1474.54 if I round it. And that would be centimeters cubed. Cubed is always volume. So centimeters cubed, or cubic centimeters. Okay, and then we have surface area of a sphere. So with surface area, that's always units squared. So if I think about the surface area of a sphere formula, that one is 4/3. Oh, no, excuse me, I'm thinking of volume. The surface area formula is just 4 pi r squared. 4 pi r squared. So we're going to plug in the information into that. So really the only thing we need to plug in is the radius. Be careful with your radius, because again, we're given the diameter. So the radius is half of this. And we're going to go ahead and plug that into our calculator. We got 4 pi times 5 squared, and I get, I'll put it over here, 314.16. That's in meters squared because it's surface area. Okay, looking at number 23, it says when making an Arnold Palmer drink, you mix 2 cups of iced tea for every 1.5 cups of lemonade. If you have 5 cups of lemonade, how many cups of iced tea would you need to make a batch of the drink? So then it says round to the nearest tenth if you need. Well, let's go ahead and highlight some information. This definitely seems like a proportions question, something where we need to set up a fraction set equal to another fraction. And I'm going to go ahead and put, for this 2 cups of iced tea per every 1.5 cups of lemonade, I'm going to put the iced tea on top and the lemonade on the bottom. So 2 iced tea, 1.5 lemonade. That means on this side I better do the same. And then one of these will be a variable. So in the next set I have 5 cups of lemonade, and then it asks how many cups iced tea. So I assume the iced tea is going to be a variable here, which means the 5 cups of lemonade on the bottom, x on the top. Cross multiply. 2 times 5 is 10, 1.5x, and then we just need to take 10 divided by 1.5 and get, because when I divide 1.5 on both sides, I get x to be 6.66, so the nearest tenth, 6.7, and that would be cups iced tea. Okay, 24, it says find the area and the perimeter of the irregular shape. So first, let's do area. I see here that, if I think of area, that I can split this into 3 shapes. And I'm going to go ahead and split it this way. You don't have to, but I like splitting it this way. So I can have a shape here, a shape here, and a shape here. This first one is definitely a square, a 6 by 6 square. So I'm going to say the area of the square is 6 by 6, so 36 meters squared. And then let me do the area of the rectangle next. So the area of that rectangle is 20 by, well, I'm looking at this height up here. Because that's 15, I know this portion right here is 6. I know that's 6. So if I take 15 minus 6, then I know my remainder would be a 20 by 9. So let me label that properly. I know this guy is 9 right here and here, because it's a rectangle. So then I can figure out, okay, that rectangle has a area of whatever 20 times 9 is, base times height, so 180. I'll make a note here. That's base times height. That's base times height. And the next one is the area of a triangle. Well, we know the triangle is 1/2 base times height. That's that formula. So I see this little triangle down here. I know if this portion's 9, the rest is 16, well, my remainder definitely has to be 7. So let me mark that as 7. I also know now I got to figure out this height. Well, again, the full height over here is 20. Okay? I'm going to subtract out this 6. Then I'm going to subtract out this 5. The remainder will be the height. Well, 20 minus 6 minus 5 gives us the height of 9. So if I erase the rest of this, I know that little height is 9. So let me plug that in. 1/2, 9 times 7. So 1/2, 9 times 7 gives me 31.5. And let's just add all these areas up. After adding them all up, I get 247.5 meters squared. So there's our area. Found the area of all 3 separate, added them together. Next, if we look at the perimeter, I think we have everything except for this distance. Well, that distance falls in a right triangle. So to find that distance, I'll put it in black over here. We need to do the Pythagorean theorem. Pythagorean theorem, that's supposed to be a G. A squared plus B squared equals C squared. Well, I know A and B. 9 and 7. I have to solve for C. Well, 9 squared is 81. 7 squared is 49. So if I add 81 and 49 together, I get 130. And then the square root of that on both sides, I'm just going to leave it for now. We'll calculate it up later. So that guy is radical 130. Let me add everything together now. I've got 20, and then going clockwise, 15, 6, 6, 5, radical 130, and then 16. Those are all of my perimeter distances if I follow around the shape here. Adding all those up, I get approximately, rounded here, 79.4, and that's just meters. So there's our perimeter. Okay, now jumping into Module 4, so the most recent module. The first question asks for the slope of a line between 2 points. Remember, the slope formula I would definitely have this down, y2 minus y1 over x2 minus x1. So we need to plug those in. We can call this point x1, y1. We can call this point x2, y2. So let's plug those guys in. 1 minus 3 over negative 4 minus 1. 1 minus 3, negative 2. Negative 4 minus 1, negative 5. Well, since I'm dividing a negative by a negative, I can just say that's positive 2/5. So there's our slope between those 2 points. Now you can always check this by plotting on Desmos. For the graph. You can always check it for the graph. Okay, write in the equation. Now the equation we focused on was slope-intercept form. Slope-intercept form. And that was of the form y equals mx plus b, where we needed to know two things. We needed to know m, the slope, and b, the y-intercept. That's all you need to plug in. So, if I can identify both of those, I'm good. The y-intercept is definitely 4. So that's our b value, 4. The slope, well, I need to find 2 points that work out. So it looks like this point and this point actually work out nicely, and I can count the rise over run. How many am I going up or down? And then how many left or right? Whoops. M equals rise over run. So the rise is 1, 2, 3, 4 down, so negative 4. And then 1, 2 over. Well, that simplifies to negative 2 over 1, or just negative 2. So I'm going to go ahead and plug that in. Y equals negative 2x plus 4. Okay, so now the next question has a table of values. It says when plugging in 10 for x, what will the value on the right be? So I know when I plug in x, I then do this math, x minus 3, and I get the right column. So when I plug in 0, 0 minus 3 is negative 3. If I plug in 4, 4 minus 3 is 1. So now if I plug in 10, well, 10 minus 3 is 7. So easy enough, our right column spits out a 7. Okay, looking at 28, given the equation, what is the slope? So again, remember y equals mx plus b. We know the slope falls with the number in front of the x. So right now, if I look at the number in front of the x, it's right here. It might be useful to shift this around a little bit. So maybe you want to change these two, the order of these two, and say negative 1.45x minus 0.87, and now it's in that spot. So negative 1.45, just the number is the slope, negative 1.45. Looking at 29, it says Jim earns a paycheck of $2,000. Each day he plans to spend $35. Write an equation to model the amount of money A after X number of days. So if Jim earns $2,000, I know that's going to be a constant. So my amount of money is going to equal $2,000. And then he spends $35 per day. So that's my rate. If X is the number of days, I'm just going to subtract out the $35 times X. And then I've got my equation for the amount of money. All right, looking at number 30, it says write the equation of a line given the slope of negative 1/3 that runs through the point 0, 7. So again, in slope-intercept form, you need to know two things. You need to know the slope and the y-intercept. I know what the slope is already. I don't know the y-intercept. So I'm going to go ahead and plug in the slope, and then I'm going to plug in this x and y point. Because when I plug in 7 and 0, I can now solve for b. Well, let's move this up here. Negative 1/3 times 0 is 0, so b is 7. Now that I know slope is negative 1/3, b is 7, let's go ahead and plug this into our final equation. Negative 1/3 x plus 7. And we're done. Again, you can check this on the graph. That line definitely goes through the point 0, 7. Okay, 31, write an equation for a line with undefined slope that runs through the point negative 3, 5. Undefined slope, remember that means vertical line. Zero slope means horizontal line. So undefined is vertical. If I think about what that looks like on a graph, it's got to go through the point negative 3, 5 up here, negative 3 for x, 5 for y, and it's got to be a vertical line. So that means it's going to run through negative 3 this whole time. So a vertical line is always x equals, and since the x value is negative 3, that's all we need to put. Again, double check on Desmos. That's going to give you a vertical line that runs through the point negative 3, 5. Okay, the next question is write an equation of a line that connects the points on the graph. So we might as well connect them. There's our line. It's definitely a horizontal line. Horizontal has a slope of 0, and it's always y equals. So it's y equals a number. Well, what's the y value on all these points? This is negative 1, 4. This is 3, 4. This is 4, 4. The y value is 4. So I'm going to put y equals 4. Last one on here. We've got a point 1, 5. Is it a point on this line? So you've got options here. Option 1, graph it. Well, I don't have a graph pulled up, so I'm going to go ahead with option 2. Plug it in to see if it's true. So if it's y equals 4x minus 1, that means x is 1, y is 5. So 5 equals 4 minus 1. Is that true? Does 5 equal 3? No. So this is not a point. We're going to say no, not a point on this line. Okay, so that takes care of all the review here. If you have any additional questions, you need to rewatch it, slow things down, feel free, or let me know. Our exam is Tuesday.